These flyaways looking like a fool. Looking like a dang fool. You're looking like a dang fool. Okay. One second. All right. Hello, everybody. Welcome back to the channel. Hope you're having a good day so far. My dog does not like to be in here when I'm talking. She just immediately bounces as soon as I start talking. She's that mad. But I'm your father. This is how you treat me. Your father. All right. Enough of that. Boom, ba-da-dum, dun, 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 boom, boom, ba-da-dum, da-da-dum. All right. Hello, one, and hello, all. My name's Mike. I hope you're having a wonderful day. So far, we're going to be back today and C programming a mod. Oh, hold on. I got to start the recording if we're going to do this one, right? This has got to go on the channel. So, let's go ahead and get a recording going here. I forgot that we record these. It's been a while since we read because we've been we've been solving these problems and doing that at the end of the chapter. It's been taking us a while. They're getting harder and harder. Okay, here we go. Let's go ahead and... Man, I got a lot of burps here. Hold on. Whew. We're doing it live. Okay, hold on. Let me go back up to the top here. All right. Hello, everybody. Welcome back to the channel. My name is Michael, and hope you're having a wonderful day so far. Today, we're going to be jumping back into C Programming, A Modern Approach, 2nd edition, K.N. King. Today, we're going to be jumping back into C Programming, A Modern Approach, 2nd edition by K.N. King. We are going to be jumping into and starting today. Let's get over to where we're going to be. Come on. We're going to be reading today Chapter 8 on arrays. So super excited to get into arrays. I've been waiting for this one. So here we go. I'm super excited to get going here. We are jumping into Chapter 8 arrays. This is the recorded version or the read-along from the live stream. If you would like to follow along as I do this live, read the chapter, solve the problems, and code live on stream, teaching myself computer science and programming almost every single day, you can join me for the live streams. Consider following along, and I hope you enjoy this condensed version. The notes that you see on the right side of my screen, which consist of the notes for the readings and the solutions to my exercises and programming projects from the end of the chapters, can be found in my GitHub repo, linked down below. Cool. All right, y'all. Super excited to get into this one. We got the recording going. This one's actually not too long. It's only like 15 pages, so we might be able to bust this one out pretty quickly. Pause. Chapter 8, Arrays. right? Cool. Who's ready to party? All right, let's get into this. Gotta take a swig. Warm up the vocal cords. Chapter 8. Here we go. Chapter 8, Arrays. If a program manipulates a large amount of data, it does so in a small number of ways. So far, the only variables we've seen are scalar, capable of holding a single data item. Is it scholar or scalar? Scholar or scalar? Oh gosh, I can't mess up on the first sentence here. I think it's scalar pronunciation.
Scalar.
Scalar, okay, we were right. So far, the only variables we've seen are scalar, capable of holding a single data item. C also supports aggregate variables, which can store collections of values. There are two kinds of aggregates in C, arrays and structures. This chapter shows how to declare and use arrays, both one-dimensional, section 8.1, and multidimensional in section 8.2. Section 8.3 covers C99's variable length arrays. The focus of the chapter is on one-dimensional arrays, which play a bigger role in C than do multidimensional arrays. Later chapters, chapter 12 in particular, provide additional information about arrays. Chapter 16 covers structures. Sweet. Awesome. This is going to be good. So let's do scalar types of variables. So we'll say variables. We'll go scalar. And this is capable of holding a single data item. And then we have aggregate, which is can store collections of values. Cool. Section 8.1, one-dimensional arrays. One-dimensional arrays. An array is a data structure containing a number of data values, all of which have the same type. These values, known as elements, can be individually selected by their position within the array. The simplest kind of array has just one dimension. The elements of a one-dimensional array are conceptually arranged one after another in a single row, or column if you prefer. Here's how we might visualize a one-dimensional array named A. We have array A is a sequence of squares here. To declare an array, we must specify the type of the array's elements and the number of elements. For example, to declare that the array A has 10 elements of type int, we would write int A bracket 10 close bracket. The elements of an array may be of any type. The length of an array can be specified by an integer constant expression. Since array lengths may need to be adjusted when the program is later changed, using a macro to define the length of an array is an excellent practice. #define big N as 10, int A with big N nested in. Okay, cool. Okay, so we got some definitions here. So an array in C, a data structure structure containing a number of data values, all of which have the same type. These values are known as elements. So the elements are the items within the array, and they can be individually selected by their position and can be individually selected by their position. We'll say the values within the array. It can be individually selected by their position. Cool. Ooh, there's a bug. Get out of here. Yo, what's up, Tim? Welcome back. Yo, Silva, what's going on? This is C Programming, a modern approach. It's right in the title, my boy. Let's okay. So we're gonna declare an array with this notation here. Int, or we'll say type, array, and we'll say x here, right? So that this is like the number of elements or something, right? Be a number. So we'll say this is declare an array. So you declare an array, you must specify the type. Specify the type and the number of elements in the array. So use this notation here. So type array elements. So we'll say like, it's not like array. We'll say like this. We'll say like array name. Semicolon. You can also use macros, right? Which is, I mean, it's fine. The length of the array can be specified by an integer constant expression. Since the array length may need to be adjusted, it can be changed later using a macro. Gotcha. Okay, cool. Let's keep pushing here. Nice, boys. Okay. Array scripting. To access a particular element of an array, we write the array name followed by an integer value in square brackets. This is referred to as subscripting or indexing the array. Array elements are always numbered starting from 0, so the elements of an array of length n are indexed from 0 to n minus 1. For example, if A is an array with 10 elements, they're designated by A index 0, A index 1 through A index 9, as the following figure shows. Expressions of the form A index I are L values, so they can be used in the same way as ordinary variables. A index 0 is equal to 1, where we assign the value at position A index 0 to the integer 1. We then print the value of A index of 5, and we increment the value of A index of I. In general, if an array contains elements of type T, then each element of the array is treated as if it were a type of, In general, if an array contains elements of type T, then each element of the array is treated as if it were a variable of type T. In this example, the elements A index 0, A index 5, and A index I behave like int variables. Arrays and for loops go hand in hand. Many programs contain for loops whose job is to perform some operation on every element in an array. Here are a few examples of typical operations on an array A of length N, where we loop for I is equal to 0 up until I is less than n. We increase I. We set the array value for every position of I as 0. For clears the array. To read data into an array, we would loop using the same for loop for I equals to 0, I less than n, I plus plus, scanf, the value, and save that into the value of the array position. To sum the elements of an array, we loop over using that same for loop and increment the sum variable by the value at the position A index I. Notice that we must use the ampersand symbol when calling scanf to read an array element, just as we would within an ordinary variable. C doesn't require that subscript bounds be checked. If a subscript goes out of range, the program's behavior is undefined. One cause of a subscript going out of bounds, forgetting that an array with n elements is indexed from 0 to n minus 1, not 1 to n. As one of my professors likes to say, in this business, you're always off by 1. He was right, of course. The following example illustrates a bizarre effect that can be caused by this common blunder. We declare an integer array to have 10 positions and a variable I. We loop from I equals to 1 up until I is less than or equal to n, and we increment I, and we clear out that position by setting the value to 0 within the array. With some compilers, this innocent-looking for statement causes an infinite loop. When I reaches 10, the program stores 0 into A index 10, but A index 10 doesn't exist, so 0 goes into memory immediately after A index 9. If the variable I happens to follow A index 9 in memory, as might be the case, then I will be reset to 0, causing the loop to start over. A doesn't exist, so 0 goes into memory immediately after A index of 9. If the variable happens to follow A index 9 in memory, okay, so it wouldn't just try to access some arbitrary garbage value overflowing from the end of the array? Well, probably not, because don't arrays have null characters or whatever at the end of them to tell you that this is the end of that memory sequence, or is that just for character sequence to form strings, which I'm sure we're going to learn about soon or get more into, right? But so it looks like if you go out of bounds on the array, instead of getting that index error, you could just reset I back to 0 and infinitely loop. Now, I resets back to 0 because so 0 goes into memory immediately after A index 9. If the variable I happens to follow A index 9 in memory, then I will be reset to 0. An array subscript may be any integer expression. A index of I plus j times 10 is equal to 0. The expression can even have side effects. I is equal to 0, while I is less than n. A index I plus plus is equal to 0. Let's trace this code. After I is set to 0, the while... Jeez, I'm do like a need like a Pepto-Bismol, or not like, is it a Pepto? No, I don't think it's Pepto-Bismol. You need like an antacid or something. Isn't it Pepto-Bismol for like the other end? Okay. Yeah, I use my MacBook webcam here. It's not that bad. The M3 one, I honestly wish if the M5 if the M5 chip series has a 4K webcam, we might have to upgrade. But I don't know. The M3 is just fine. It doesn't. It's more than powerful for anything that I'm doing. Okay. Um, let's trace this code. After I is set to 0, the while statement checks whether I is less than n. If it is, 0 is assigned to a index of 0, I is incremented, and the loop repeats. Note that a plus plus I wouldn't be right because 0 would be assigned to a index of 1 during the first loop iteration. Right, because when we do the plus plus before, that does the increment within this line, right, and has higher precedence. Whereas the plus plus that happens after the variable happens whenever C does those sequence breaks, whatever, which usually happens at certain places in I don't know, is it like the call stack or is it within certain, I'm not exactly sure how it implements that, but I talked about it earlier in an earlier chapter. I honestly we haven't used that in a while, so it's a good refresher. Be careful when an array subscript has a side effect. For example, the following loop, which is supposed to copy the elements of the array B into the array A, may not work properly. I is equal to 0, while I is less than n, A index of I equals to B index of I plus plus. The expression A index of I equals to B index of I plus plus accesses the value of I and also modifies I elsewhere in the expression, which, as we saw in section 4.4, causes undefined behavior. Of course, we can easily avoid this problem by removing the increment from the subscript and just using a for loop and incrementing as the final thing to move the for loop forward. Program. Reversing a series of numbers. Our first array program prompts the user to enter a series of numbers, then writes the numbers in reverse order. Enter 10 numbers. So they enter 10 numbers here in 2, 1, or 3 digits, it looks like. And then it prints in reverse order the array reversed. Our strategy will be to store the numbers in an array as they're read, then go through the array backwards, printing the elements one by one. In other words, we won't actually reverse the elements in the array, but we'll make the user think we did. Reverses a series of numbers. We include the standard I/O. We define a macro n to be an integer of 10. Or a numerical whatever expression, integer expression 10, right? Int main void for our main function. We define a variable which holds integers of size spaces n with the array a and a variable I. We prompt the user to enter numbers based on the amount of the macro. We loop over from 0 to I less than the length of the array, and we read in what the user put into those array places. We then print in reverse order, and we loop from I equals to n minus 1, while I is greater than or equal to 0, and we reduce I. So we'll start at n minus 1, the last element in the array, and continue decrementing or reducing I down as long as I remains above or equal to 0, so the first place in the index or array. We will then printf the value of that array position. This program shows just how useful macros can be in conjunction with arrays. The macro big N is used 4 times in the program in the declaration of A. In the printf that displays a prompt and in both for loops. Should we later decide to change the size of the array, we need only edit the definition of the macro big N and recompile the program. Nothing else needs to be altered. Even the prompt will still be correct. Array initialization. An array, like any other variable, can be given an initial value at the time it's declared. The rules are somewhat tricky though, so we'll cover some of them now and save some others until later. The most common form of array initializer is a list of constant expressions enclosed in brackets and separated by commas. ah. So we have int array A with 10 spaces is equal to, looks like this kind of set or sequence of numbers going from, it's not a set, right? It would be just an array, but it's using that kind of Python set notation, if you're familiar. 1, 2, 3, 4, all the way to 10. If the initializer is shorter than the array, the remaining elements of the array are given the value of 0. Nice. Using this feature, we can easily initialize an array to all zeros. Int array 10 equals to bracket 0 bracket initializes the array to all zeros. It's illegal for an initializer to be completely empty, so we've put a single 0 inside the braces. Man, dude, I got some burps going on. I had some shrimp for dinner, so I shouldn't be nothing like have a Costco hot dog or something. What's going on here? All right, where were we? It's illegal for an initializer to It's illegal for an initializer to be completely empty, so we've struggling. It's illegal for an initializer to be completely empty, so we've put a single 0 inside the braces. It's also illegal for an initializer to be longer than the array it initializes. If an initializer is present, the length of the array may be omitted. So we can omit the array length to be declared within the actual initializer. The compiler uses the length of the initializer to determine how long the array is. The array still has a fixed number of elements, just as if we had specified the length explicitly. In C99, designated initializers. It's often the case that relatively few elements of an array need to be initialized explicitly. The other elements can be given default values. Consider the following example, where we have an array of integers with 15 places in it. And we have random kind of zeros throughout. We want element 2 of the array to be 29, element 9 to be 7, and element 14 to be 48. But the other values are just 0. For a large array, writing an initializer in this fashion is tedious and error-prone. What if there were 200 zeros between the two non-zero values? C99's designated initializers can be used to solve this problem. Here's how we could redo the previous example to use a designated initializer. So we have int a equals int a with 15 places inside. And within the array constructor, we actually specify the index and set that equal to the value we want, thus inferring all the other places as 0. Got you, cool, that's a neat trick. Each number in the brackets is said to be a designator. Besides being shorter and easier to read, at least for some arrays, designated initializers have another advantage. The order in which the elements are listed no longer matters. Thus, our previous example could also be written the following way, a different order, right? Because it's actually going based on the index and filling in zeros. Now, is that just a feature of, well, it's probably standard, right? If it's in the C99, so it's not like compiler base, it's like standard.
You're not that guy, pal. Trust me. You're not that guy.
Oh.
Okay. Okay?
Thank you.
Absolutely.
Thank you for the sub. Appreciate you, Abishk. Thank you. Stoic, how's it going? Welcome in. Let's catch up on some chats. What's going on, Poc Dev? What's going on, Silva? What's up, Bernardo? Good night, following you from Brazil. Hey, dude, what's up? Hopefully you watch the playback. Okay, we'll go back through and take notes at the end of the section. Designators must be integer constant expressions. If the array being initialized has length n, each designator must be between 0 and n minus 1. However, if the length of the array is omitted, a designator can be any non-negative integer. In the latter case, the compiler will deduce the length of the array from the largest designator. That's cool too. So you don't have to actually specify the length specifically. It'll go by the max designator that you specify, and that'll be the last element. Oh, nice. In the following example, the fact that 23 appears as a designator will force the array to have length of 24. So we declare an integer array B with an empty size, and we actually say, use some designators here, where 23 index is set to 13. So it has 0 to 23 are included, so 24 spots total. An initializer may be used. This word is killing me, dude. An initializer may use both the older element by element technique and the newer designated technique. Interesting. The initializer specifies that the array's first three elements will be 5, 1, and 9. Element 4 will have the value of 3. The two elements after will have values of 7 and 2. Finally, the element 8 will have a value of 6. All elements for which no value is specified will default to 0. Program. Checking a number for repeated digits. Our next program checks whether any of the digits in a number appear more than once. After the user enters a number, the program repeats either repeated digit or no repeated digit. Enter a number, 28212. This reports repeated digit. The number 28212 has a repeated digit, 2. A number like 9357 doesn't. The program uses an array of Boolean values to keep track of which digits appear in a number. The array named digit seen is indexed from 0 to 9 to correspond to the 10 possible digits. Initially, every element of the array is false. The initializer for digit seen is false, which only initializes the first element of the array. However, the compiler will automatically make the remaining elements 0, which is equivalent to false. When given a number n, the program examines n's digits one at a time, storing each into a digit variable, and then using it as an index into digit seen. If digit seen for said digit is true, then digit appears at least twice in the index. Then digit appears at least twice in n. On the other hand, if digit seen index of digit is false, then digit has not been seen before, so the program sets digits to true at that position for that digit and keeps going. Repeat digit checks the number of repeated digits. We include the standard bool and the standard IO. We have bool digit seen array with 10 positions is equal to all false positions. We declare an integer digit and a long n. We print f, enter a number, and we scan that into the long value n. While n is greater than 0, we modulo the value by 10 to remove the rightmost digit. If the digit indexed into digit seen, right, we break, meaning that we've already seen this value. If the digit, oh my gosh. Dude, I'm talking too much. Come on. Push through, push through. We got this. That's lemonade. I gotta get some water. So we do the Boolean kind of evaluation if digit seen index of digit, meaning if that's true, we're going to break. If it's not, we're going to set it to true, meaning that we've now seen this digit, and then we're going to set n to equal the division of n divided by 10. To then decrease n down to the next smaller number so we can, of magnitude, right? So we can kind of get the, do the next digit pull off, right? If n is greater than 0, meaning that we went through all of this, right, we're going to print that we repeated a digit, else no repeated digit, and return. Interesting that they did this evaluation here, right? If you know you're going to break right here, why not throw that print right before the break? And then what happens after the while loop, if you never hit the break, you go ahead and just print out there's no repeated digit, like as a default. So then you don't even need this, right? Now, didn't we learn about something that no, the do while does something automatically once. Oh no, that was Python. Sorry, I was thinking back to my one of my recent uploads for the Python crash course videos where you can use break, or sorry, you can use else with for loops, right? If you never hit a break, it'll hit the else statement, right? So you could do it that way too. So with that's Python. Never mind. Sorry, sorry. Don't kill me. I know I'm talking about the Python. Okay. Oh, got you. Because if you break out, it'll automatically print a no digit repeated. Right. I guess that's where Python's a little nice, giving you that for else. So you can yeah. Cool. This program uses the names bool, true, and false, which are defined in C99 standard bool.h header. If your compiler doesn't support this header, you'll need to define these names yourself. One way to do so is to put the following lines above the main function. Hashtag define true 1, hashtag define false 0, type def int bool. Notice that n has a type long, allowing the user to enter numbers up to 2.15 billion. And more or more on some machines. Using the size of operator with arrays. The size of operator can determine the size of an array in bytes. If array A is an array of 10 integers, then size of A is typically 40, assuming that each integer requires 4 bytes, right? 4 bytes for each integer. For 10 integers, 4 times 10. We can also use the size of to measure the size of an array element, such as A index of 0. Dividing the array size by the element size gives the length of the array. Oh, interesting. So you can take the size of the array to get its total number of bytes, and then divide it by the size of the element of each, right, of whatever's in the array. Because we know that the array, if it's a size of ints, right, it's type int, then there are going to be all integers in there. So you divide it by how many of the integers, that gives you the length of the array. Some programmers use this expression when the length of the array is needed. To clear the array A, for example, we could write for I equals to 0, while I is less than the size of A over the size of A index of 0, I plus plus, A index of I is equal to 0. With this technique, the loop doesn't have to be modified if the array length should change at a later date. Using a macro to represent the array length has the same advantage, of course, but the size of technique is slightly better since there's no macro name to remember and possibly get wrong. One minor annoyance is that some compilers produce a warning message for the expression I is less than size of A over size of A index 0. The variable I probably has type int, a signed type, whereas size of produces a value of type size underscore t, an unsigned type. We know from section 7.4 that comparing a signed integer with an unsigned integer is a dangerous practice, although in this case it's safe because both I and size of A over size of A index 0 have non-negative values. To avoid a warning, we can add a cast that converts size of A over size of index 0 of A to a signed integer. So we can say for I is equal to 0, while I is less than an integer casting to the value of size of A over size of A index 0, I plus plus. And we set all the values in the array to 0. Writing int size of A over size of A index 0 is a bit unwieldy. Defining a macro that represents it is often helpful. If we're back to using macros, if we are back to using a macro, though, what's the advantage of size of? We'll answer that question in a later chapter. The trick is to add a parameter to the macro. Okay, so program, computing interest. Our next program prints a table showing the value of 100 invested at different rates of interest over a period of years. The user will enter an interest rate and the number of years the money will be invested. The table will show the value of the money at 1-year intervals, at that interest rate and the next 4 higher interest rates, assuming that the interest rate is compounded once a year. Here's what a session...
You're not that guy, pal. Trust me. You're not that guy.
Okay. Hey, thank you so much.
Okay? You? Absolutely.
Liz Chow.
You're not that guy,
Hey,
pal. Trust
Zagnick.
me. You're not that guy.
We're back to back.
Okay?
Look at that, back to back.
Absolutely.
The train rolling. Our next program prints a table showing the value of $100 invested at different rates of interest over a period of years. The user will enter an interest rate and the number of years the money will be invested. The table will show the value of the money at 1 year intervals at that interest rate and the next 4 higher interest rates, assuming that interest is compounded once a year. Here's what a session with the program will look like. Enter interest rate 6. Enter the number of years 5. So years 1 through 5 gives 6%, 7%, 8%, 9%, and 10%, and the value of $100 compounded annually at those interest rates. Clearly, we can use a for statement to print the first row. The second row is a little trickier, since its values depend on the numbers in the first row. Our solution is to store the first row in an array as it's computed, and then use the values of the array to compute the second row. Of course, this process can be repeated for the third and later rows. We'll end up with 2 for statements, one nested inside the other. The outer loop will count from 1 to the number of years requested by the user. The inner loop will increment the interest rate from its lowest value to its highest value. Interest.c prints a table of compound interest. We include the standard io.h, and we define a macro of numRates, which is equal to the int cast of size of value over the size of value index of 0. We then define initial balance as 100. So you can actually define kind of a variable within this macro, even without the macro knowing before what that variable is. So it kind of trusts you to make sure you put it in the right place. Okay, so we have a main function. We declare integers I, low rate, num years, and year. We declare a double, which is an array value with size 5. So 5 double values, or floats value, right? Double precision floats. We're going to print enter the interest rate. We're going to scan that into the low rate integer variable. We're going to print enter the number of years. We're going to scan and read that into the number of years variable. We're going to print \n years to get this effect here. For I is equal to 0, while I is less than the numRates, we're going to increase I. We're going to print the integer value, low rate, plus I, right? So this is the increasing of the integer for the rates. So we're going to have 6 number of rates, right? Or 5 years, we're going to have 5 rates increases. So
You're not that guy, pal. Trust me. You're
I'm
not that
throwing
guy.
headphones for this. I appreciate all the
Okay.
subs.
Absolutely.
Appreciate all the subs. I got to throw in the headphones though, so we can keep pushing. We'll do one out. Hey, yeah, we got it rolling now. Everybody's rolling in. Let's go, boys. Hey, what's up, Brooke? Mustafa, well, thanks for joining me, everybody. We're reading C Programming: A Modern Approach, 2nd edition by K.N. King right now. Got notes on the right side of my screen. You can find in my GitHub link down below, along with all the chapters, exercises, and programming projects and stuff we've been working on. We are doing chapter 8 right now. We're moving on here, so thank you guys so much for being here. So where were we? Right, so we're going to print f, a integer with 6 spaces of field space, where we're going to insert the low rate plus I. We're then going to, so the first one will be 0, so it'll be the initial rate of, whatever rate they put in initially, so 6%, and then 7%, so rate plus 1, rate plus 2, rate plus 3, rate plus 4, and then end, right? We're then going to insert the initial balance into the value of that I value for that index. So 0 will go in initially, and then we'll do some work on zero on that initial balance, and then the initial balance gets resaved back in there, as I think that's probably what's going to happen here, maybe. Computing low rate. So for every year from 1 to the number of years included, we're going to increase the year. We're going to print with 3 spaces of field width and then a bunch of just spaces here. And then we're going to insert the year value. We're then going to loop for 0 up until the number of rates plus plus. We're going to insert into the value okay, so interesting. So what it does is that we initialize the initial balance for all of those to the initial balance. Okay. Because they're all the initial balance. What is it? It's just doing this here. It's not actually, and then it's taking, okay, that's taking that reference value and then doing an adjustment to it here, right? So it's going to take the value at that index, right? Use the previous value in addition to compound the next year. And then print out the value. Note the use of num rates to control 2 of the for loops. If we later change the size of the value array, the loops will adjust automatically. Cool. All right, y'all. Hold up. What's up, everybody? All right, let's see here. What's going on, Rakoli Devong? Hey, Tushar SNX, how's it going? Welcome. Sorry, getting caught up on some chats here. Um, Ever thought of doing like day in life and changing the directory of the channel just a little? Just asking, like, would it be cool? I don't know. I don't really want to be like a regarding your question. So Stoic asked me. This is kind of off the topic. Have you ever thought of doing day in the life and changing the trajectory of the channel? Honestly, no. I don't have any desire to do that at all. I do not want to be. I'm not someone like I'm not an influence. I'm just a normal person. I think that there's people out there that are doing it far more than that you should look up to, and actual people that you should look up to out there that or whatever. I know I'm just someone a normal person just learning programming. I wouldn't. I don't want. And I'm kind of a little bit kind of private. I don't really want to. You know, this is about as far as I'll go for like kind of giving up like information about myself. Really, like I don't know. In my daily life. Uh, um, Good that we're learning C, avoiding macros. People are saying. Um, Sorry, I'm getting caught up on chats, everybody. Are you practicing active recall? Space rep? I don't know. I don't follow along with any of that mumbo jumbo studying techniques. Just, just keep doing it. You know, it's not rocket science. The more you do things over and over again, the better you'll get at them. Now, you have to at least put in some, at some point, you have to start actually putting in some levels of effort to compound for the like difficulties as it gets harder and harder because you're no longer learning, it's like the learning curve starts to, steepen, but I don't really get into all that kind of, all those like methods of learning or whatnot. I don't know. I think it's just people try to maybe make it too difficult to just sit down and read and grind and try and try and try and try. I'm learning Python and linear algebra right now. Nice, dude. Sounds awesome. Let us know how that's going, Ronan. How do you take notes? It's just with Markdown in VS Code here. I just like to keep things simple. I don't really need to take things too far. People have recommended some other stuff for note taking, but if it's not broke, don't fix it. It's simple Markdown page is enough for me, really, with the Command F to search for something. Multi-dimensional egg cartons. You prefer tech interviews, a lot of mostly cloud questions. Okay, cool. Then we're caught back up here. We're caught back up. What's up, everybody? We got 32 people in here. My name is Michael. I've got a degree in human biology and a minor in chemistry. I've been teaching myself computer science and programming almost every single day for the past about year and a half, reading books like Fluent Python, Python Crash Course, doing courses CS50, reading books like this, and whatnot. So if you like stuff, building live projects, original projects, like not really not vibe coding, just like raw learning and building and coding. Yes, I do reference the AI to ask questions and dive deeper, but most like 95 to 99% of the code I write is all myself. I try to do that on purpose in this stage of learning. Yeah, but I don't say I don't use it because I would do use it because it is helpful for getting quick answers to some questions and stuff, and diving deeper and breaking things down too. Okay, where were we? Okay, we need to take some notes. Oh boy, this section was long here. Pause. Okay, so we started off with this one. I think we're on array subscripting here. Okay, so let's just quickly get some notes going. An array subscripting, right? To access a particular element of an array, we write the array name followed by an integer value in square brackets. Well, so for these notes, because we're kind of going back through to get some, we read it, go back through, and then we do practice, so we get a lot of hits. But yeah, okay, cool. And referred to as subscripting or indexing, right? Cool. Array elements are always numbered from 0 to length of n minus 1. Array elements are always numbered starting from 0, so the elements of an array of length n are indexed from 0 to n minus 1. So we'll take this picture here and get this into our notes here. Like so. Like so. Okay. These are L values, so we'll say expressions of the form A, and we'll say like A index of I are L values, right? And can be used like ordinary variables. So we'll just quickly grab this guy. Noise. In general, if an array contains elements of type T, then each element of the array can be treated as if it were of type T. This one has a lot of good little bullet points, right? Might be kind of being overkill, but it's whatever. If an array, in general, if an array contains elements of type T, then each element of the array is treated as if it were an element of type T. Okay. Arrays and for loops go hand in hand. You can do for loops, so we'll do arrays and for loops. So honestly, I'm just going to take a screenshot of this guy here. Right out of the book. Cool. Right, we're just doing looping, indexing. We've seen this stuff before. Pretty universal here. C doesn't require that the scripting bounds be checked. If a superscript or subscript goes out of the range, the behavior is undefined. Okay, so we'll put that into here. Range of the program's behavior is undefined. One cause of subscripting programs bounds for getting an array of elements off by one. Yeah, that's okay. With some compilers, innocent looking for loop statements cause an infinite loop, right? We'll say some compilers cause infinite loop when off by one. Where I is reset back to 0 when accessing the like the out of bounds. I don't know, like, is that like accurate? Let's kind of get some feedback on this one here. Can I get some feedback on this, please? Ah, stop doing that. Hold on. Feedback, please. C does not require bounds checking. Accessing an array outside the bounds is undefined behavior. Some compilers cause infinite loops when off by one. What's actually that when you go out of bounds, you may overwrite adjacent memory. That memory might contain the loop variable I, a pointer, a condition variable. If I repeat appears to reset to 0, it's because your program corrupted memory, not because your compiler decided to reset it. Why this matters. Arrays don't know their size. The compiler generates no runtime checks. Out of bounds access means anything can happen, including infinite loops, crashes, silent corruptions, or working by accident. The compiler is allowed to assume your code is correct. Once you invoke undefined behavior, all bets are off. Out of bounds writes may corrupt nearby memories. So yeah, that's what I thought. Like I thought that it would not access a potential place, or it says it might be compiler dependent, right? Uh, um, mm, mm, mm. What is, Yeah, exactly, Brolix, pretty much. We've already we've learned kind of a more intermediate level of Python knowledge, built some cool stuff in there. Now we're kind of diving deeper. Um, Sorry, getting caught up on some chats here. I'm reading Fluent Python right now. I'm about a quarter of the way through it. I kind of go on and off stream reading it. That one I'm not as, I read that one kind of on and off in my spare time. Okay, so let me just get rid of this thing. An array subscript can be an integer expression. Be careful when subscript has a side effect. Right, we learned about that. It's fine. Don't need to take notes on that one. This is an example, reversing numbers, cool. Okay, array initialization, this one's a good one. Array initialization. So remember, this one talked about how we can actually, declare those elements in the array, initialize them, and we can do that in a couple of cheeky ways. So the most common form of array initializer is so this is, we'll take this one. Okay. If the initializer is shorter than the array, the remaining elements are always given a 0 value. So we'll say it's annoying how it does that. If the I can never spell this word. Initializer is shorter than the array length defined, the blanks are filled with 0. Cool. So we'll say a list of constant expressions enclosed in brackets and separate commas. I'll just take this guy and put it here. And then we'll go and take this, put it like there. Copy image. Put that there. Okay. Using this feature, we can easily initialize it to all zeros with this effect here. So I like all these examples, so I'm going to take them for quick lookup. They seem pretty nice. For like quick little things you can do. Then if initializer is present, the length of the array may be omitted. If an initializer is present, the length of the array may be omitted. Is it 1M or 2? 1. And then we'll take this one. Nice. Cool. It's designated initializers. Okay, it's cool. So now we have this new thing, this thing right here. We'll say designated initializers. This was C99. Initializers. Okay. So remember that if we have kind of sporadic elements, we can actually specify them directly with their index, and the zeros are filled. So it's pretty cool that way. So for For a large array, writing an initializer in this fashion is tedious or prone. So we'll say specify specific initialize. We'll say initialize specific index locations during array initialization. We'll say yeah. Initialize. I guess it is initialize specific index locations during array initialization. Non index locations not mentioned are filled by 0. Yeah, we'll go with that. And then we'll say order does not matter. Cool. Let's go. Each number in the brackets is said to be a designator. We'll say each number in the brackets is said to be a designator. Is this a bracket? Because we have multiple brackets here. These are braces, right? This is and braces. These calls these braces and these brackets. Okay, braces, brackets. Cause lots of rackets. Okay, so the numbers in the brackets, in the brackets are designators, not braces. Okay, braces, brackets. Oh boy. So designators must be integer constant expressions. They must be integer constant expressions. Between 0 and n less than 1. Where n is the length of the array. We'll be specific. Cool. The largest, we'll also say if the size of the array is omitted, the largest designator defines the last position. Or something like that. The largest designator defines the b plus 1. So it'd be largest designator plus 1 defines the. So the array length equals to the largest designator plus 1. Nice. I'll take this guy here. Nice. Moving along. Okay, this does check repeated numbers. That one's fine. Nothing we need to worry about there. It just gives us an example, which is good. You can use the size of here. Okay, using size of operator with arrays. Let's get some notes here. Using the size of operator with arrays. The size of operator can determine the size of an array in bytes, right? We remember that. Okay. We can also use size of to measure the size of an element in the array. Right? Such as A index 0. We can also use the size of to measure the size of an array element, such as A index of 0. Okay. Dividing the array size by the element size gives the length of the array. Take this, go right, like that. Boom. Some programmers use this expression when the length of the array is needed. So we can go like this. Let's take this guy here. Copy that image. There. Cool. This might do a warning message. So we'll say may produce a warning message when comparing int size type with size t type cast the size of array A to promote this value. We know that section 7.4 comparing signed integer with unsigned integer is dangerous. We can avoid this. We can cast add a cast that converts this to a signed integer. Oh, it's the whole thing to a signed integer. Oh, so it's comparing I integer to a type. Sorry. When comparing I of type int, right? This is a signed type with size t with the size of A over size of A index 0. Right. Of size t int cast int all of this to promote this value to for this value. may produce a warning message when comparing I of type int, which is a signed type, with the size of A over size of A index 0 of size T type, cast int of size A over size of A index 0 to promote this value. Cool. And then we got the interest problem here that we looked at. And then we're now on to 8.2 here. So 8.2. I think we only have like five more pages. Yeah, we're almost done. Oh, let's go. We're almost done. Yeah, they really don't touch too far on multidimensional stuff here. So we're almost done with this chat. Let's keep pushing. Let me catch up on some chats and we'll keep pushing. Maybe I'll go to the bathroom real quick. We'll take a quick 5-minute break. Or not 5 minute, like a 2-minute break. Or maybe here in a second. Hold on, let me catch up on some chats. Lots of chats coming in. What's up, everybody? I appreciate everybody for being here, hanging out with me today. Hope everybody's enjoying the stream and enjoying the book reading. Let me know how you feel about the content. If you have any suggestions, let me know. If you have any, if you enjoy it, it's great to hear feedback. Leave a like if you enjoy it. As far as the C spec is concerned, accessing a raise out of bounds is undefined, but most compilers will catch that and flag it. If not, that's major security. If not, that's major. Considered a major security. I'm suffering with a lot of problems. No, I had a lot of fun making interpreter, compiler, allocator, shell, scheduler for all uni classes. Nice. Yeah, I want to get into systems programming, a programmer or a systems or something, a programmer's perspective. Has some like server stuff that you can do. It walks you through that process later on in the book. So I'm hoping to get to that when I read that part. You can do that with any language type system. Piloting, talking about compilers. Nice. Imagine a magical egg cart and it can be any size and egg represents a variable. What's up, Ray? Did your biochemistry program cover any coding or pseudocode? No, it did not. And my guess, in my opinion, if you want to ask me, is with the influx of AI. I called this from like 2 or 3 years ago, not even that. I called this like 4 or 5 years ago, 6 years ago, maybe, and maybe longer than that. I really thought that, no, even longer than that. When I was in high school, I said that I really think that computer science should be a core curriculum with math, writing, English, and science, or whatever. It should be computer science is intertwined. Like I really felt like passionate that, and I kind of was even on the game back then, but now I mean I didn't know about AI back then, but no, I really felt that the United States needed to ingrain it in its education curriculum as a core subject, but United States education is just shattered. It's been on the down slump for years and years and years. Poor kids nowadays, dude. I'm highly considering homeschooling my kid when the time comes. It's unfortunate. It's just public schools is tragic. Anywho, we don't need to get into that. Let's keep going. Um, Most of the CS grad programs these days barely even touch how computers actually work, so students have no idea stack versus heap. Crazy. Calling yourself a computer scientist and not knowing how computers work is wild work. Um, Sorry, lots of chats I'm getting caught up on. Holy crap. You guys are awesome talking it up. Sorry, y'all. I'm sorry I missed everything. Arrays. Sorry. They do leak code that asks know any fundamentals. What is fundamental? I'll see you next stream. Thank you for being kind. See you, Ronan. Appreciate you for coming in. Okay, cool. Nice. All right, here we go. Let's keep going here. My stomach's kind of hurting, so we got to kind of wrap this up. Okay. 8.2 Multidimensional arrays. An array may have any number of dimensions. For example, the following declaration creates a two-dimensional array, a matrix in mathematical terminology. Int M5 9. The array M has 5 rows and 9 columns. Both rows and columns are indexed from 0 as the following figure shows. To access the elements of M in row I, column J, we must write M index I, index J. The expression M index I designates the row of M, and M index I, index J then selects the element J in this row. Resist the temptation to write M index I, comma J instead of the two indexes separate. C treats the comma as an operator in this context, so MI comma J is the same as just MJ. Although we visualize two-dimensional arrays as tables, that's not the way they're actually stored in a computer's memory. C stores arrays in a row major order, with row 0 first, then row 1, and so forth. For example, here's how the M array is stored. Row 0, row 1, all the way up through row 4. We'll usually ignore this detail, but sometimes it will affect our code. Just as for loops go hand in hand with one-dimensional arrays, nested for loops are ideal for processing multidimensional arrays. Consider, for example, the problem of initializing an array for use as an identity matrix. In mathematics, an identity matrix has ones on the main diagonal where the row and column index are the same and zeros everywhere else. We'll need to visit each element in the array in some systematic fashion. A pair of nested for loops, one that steps through every row index and one that steps through each column index, is perfect for the job. We define a macro, big N, of 10. We call it double ident, which is our array, or a multidimensional array of size 10 by 10, 10 rows and 10 columns. For every row equal to 0 up until the maximum amount of rows, and for every column equals 0 up until the maximum amount of columns. If the row is equal to the column, then we're going to go to that array position at row, column, and set it to 1. Else, we set the value to 0. So wherever the row and column are equal to one another, thus creating that kind of intersection. Multidimensional arrays play a lesser role in C than in many other programming languages, primarily because C provides a more flexible way to store multidimensional data, arrays of pointers. Initializing a multidimensional array. We can create an initializer for a two-dimensional array by nesting one-dimensional initializers. Int M index 5 index 9 equals to brackets, where we have arrays for each row. Each initializer provides values for one row of the matrix. Initializers for higher dimensional arrays are constructed in a similar fashion. C provides a variety of ways to abbreviate initializers for multidimensional arrays. If an initializer isn't large enough to fill a multidimensional array, the remaining elements are given the value of 0. For example, the following initializer fills only the first 3 rows of M. The last 2 rows will contain zeros. So we have 5 rows here, but only 3 are given in the initializer, so the last 2 are filled with 0. If an inner list isn't long enough to fill a row, the remaining elements in the row are initialized to 0. We can even omit the inner braces. Once the compiler has seen enough values to fill one row, it begins filling the next. Interesting. Okay, so it's like rather than one long array, because you have initialized a row, a multi-dimensional array, it'll fill one row and then move to the next row, and then to the next, and to the next. Okay. Omitting the inner braces in a multi-dimensional array initializer can be risky. That's what I kind of thought. That's kind of what I was. It's like it seems kind of risky. Since an extra element, or even worse, a missing element, will affect the rest of the initializer. Leaving out the braces causes some compilers to produce a warning message such as missing braces around initializer. C99's designated initializers work with multidimensional arrays. For example, we could create a 2x2 identity matrix as follows. Double ident 2x2 equals to 0, 0 is 1.0 and 1, 1 is 1.0. As usual, all elements for which no value is specified will default to 0. Constant arrays. Any array, whether one-dimensional or multidimensional, can be made constant by starting its Any array, whether one-dimensional or multidimensional, can be made constant by starting its declaration with the word const. Const char hex chars empty array is equal to these values 0 through 9, A and through F. An array that's been declared const should not be modified by the program. The compiler will detect direct attempts to modify an element. Declaring an array to be const has a couple of primary advantages. It documents that the program won't change the array, which can be valuable for information for someone reading the code later. It also helps the compiler catch errors by informing that we don't indent It also helps the compiler to catch errors by informing it that we don't intend to modify the array. Const isn't limited to arrays, it works with any variable, as we'll see later. However, const is particularly useful in array declarations because arrays may contain references information that won't change during program execution. Oh, sorry, God, my stomach is hurting. It's like really bothering me. Let me catch up on some chats here. Bro said it's getting boring. See y'all. Bro must not like programming. I asked to look at your repos and how have you been curating them over time? You can't hide much from me when I can see that data. What? Yeah, all my GitHub stuff is everything we built is live on the stream here. We've been doing this for a year and a half now, so we built quite a few stuff. Not like anything crazy, but some stuff. Um, oh my stomach is killing me. Yeah, I gotta take. Give me 1 minute. Hold on, guys. Give me like 5 minutes. Yo, I'm sorry, guys. I gotta call it. I'm not feeling too well. I might come back later and finish this up, but I'll be back. Peace out, guys.